All right, chemistry, I'm going to go through how to name covalent or molecular compounds. So Willamette Promise refers to them as covalent. A lot of times they're called molecular. And even instead of using the word compounds, a lot of times we just shorten it and say molecules. So we're going to name some covalent molecules today. And covalent molecules, the easiest way to identify if something is a covalent molecule is to look and see what kind of elements it's made up of. So we're going to be forming these compounds from only nonmetals. Okay, and we're going to be making combinations of two different elements. So we're going to call these binary covalent compounds. The binary means that there's going to be two elements. And the covalent means that they're made of only nonmetals. Okay, so probably the most recognizable binary covalent compound that you guys will recognize is CO2, which you guys know as carbon dioxide. So we can break this down. So we already can see that the C stands for carbon. And we know that maybe the oxygen is related to this oxide, and that's true. Usually we take the ending of that second element, so oxygen in this case, and we replace the ending with the suffix IDE, so ide, to show that it's a compound. And then this prefix di stands for two. Okay, so we've got a series of prefixes. I'll write them over on the side. 1, 2, 3, 4, 6, 7, 8, 9, and 10. Okay, and I can scroll through these. So the prefixes we're going to be using are mono for 1, di for 2, tri for 3, tetra for 4, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Okay, so there's the 10 prefixes. Now there's certain cases where we use them, certain cases where we don't, and then there's some modifications to them throughout. So I'm just going to go through a series of examples. So just remember, these prefixes are only used for covalent compounds. Okay. So we're going to talk in class in the Zoom sessions about ionic compounds, acids, and some other molecules. So these ones are only used for binary covalent compounds. So I should actually squeeze in the word binary here. Okay, binary covalent compounds. And so just to prove to you, right, carbon dioxide is a covalent compound because carbon and oxygen can both be found up in that right-hand corner of the periodic table. So we're going to stick with those. So let's try some more. Let's go with this one, SO3. So this one would be named sulfur, and the prefix for 3 is tri, so sulfur trioxide. We can mix it up. Let's go with P2Cl5. So P2Cl5 has 2 atoms of phosphorus. So this would be diphosphorus. Okay, so no modification to the ending of phosphorus. And then pentachloride. Okay, and chlorine, right, is Cl. So I modify the second element to end in IDE. So chlorine becomes chloride, right? These all have the same prefix. This tells me that they're binary covalent. Okay, and then I use the prefix penta to represent the 5 and the prefix di to represent the 2. Okay, so diphosphorus pentachloride. Now we get some weird ones when we have, say, C and O. Now you guys will recognize maybe this one as carbon monoxide. Okay, we C for carbon, right? And then mono or monoxide, that's the prefix for one. And you're thinking, well, don't I have one carbon and one oxygen? So why don't I put a mon or monocarbon? And the rule of thumb, or the way that we've kind of decided to do this, on a binary covalent compound, if there's one atom of the first element, so like carbon in this example, then we don't use mono there. We just say the element's name. So if there's one carbon to start with, we just say carbon. But if there's one oxygen or one of the second element, we do use the prefix mono. Okay, so for example, we can do another one. If this was, say, N2O, this would be dinitrogen and monoxide. But if I had NO, okay, well, I have one of each, one N and one O. I just say nitrogen monoxide. Okay, or if I had NF, this would be nitrogen monofluoride. Okay, let's go with SEI. So let's see, Se7I6. So this would be hepta is the prefix for 7. Heptaselenium. And then hexa iodide. Hexaiodide, right? So selenium or heptaselenium hexaiodide. Okay, what if I had, let's go with octa. Pick one that I haven't used. Small one. So I'm back to that single xenon. Okay, only one of them. So I'll just use the word xenon, no mono. And then octa bromide. And if it was the other way around, I know this would be strange. And a lot of these compounds don't exist in nature, but this is how we would name them if they do. This would be octa xenon mono bromide. Okay, so again, the rules of thumb: use mono only if there is one of the second element. Never use mono on the first. Oops. Okay. Use other prefixes for both the first and the second element. And then end the compound name in I. Okay, and that only goes on the second element. Okay, so there's your rules, and maybe write these down for naming binary covalent. Sorry, I almost said ionic. Covalent compounds. Okay, and again, the other word for covalent compounds is really called molecules. So naming binary molecules, these are the rules that we would use. Okay, hopefully that gets you started. We'll probably go through more examples. There are some more kind of nuances, like triiodide. You have to put two I's together, and hexoxide. I don't think we say hexaoxide. So there's just some things to to practice and get more familiar with, but those are the basic rules. So hopefully that gets you going. You're going to try the quizzes that I've got set up, and when you've gone through the quizzes once or twice and you're feeling pretty good, you're going to report those results to Canvas. Okay, so this is your first asynchronous day, and then we'll have another one of these or something similar for the second asynchronous day, maybe a lab, I think. All right, good luck.